Algorithm and flowcharting. Programming tools. These are the tools used to convert algorithms into computer programs. We have two, flowchart and algorithm. Flowchart graphically depicts the logical steps to carry out a task and shows how the steps relate to each other. Algorithm is a systematic logical approach which is a well-defined, step-by-step procedure that allows the computer to solve a problem. Let's have a problem-solving example. How many stamps do you use when mailing a letter? One rule of thumb is to use one stamp for every 5 sheets of paper or fraction thereof. Let's solve the problem using the algorithm. First, request the number of sheets of paper, so that is our input. For the processing, we have steps number 2 and 3. Divide sheets by 5. Round the quotient up to the next highest whole number. And lastly, for the output, reply with the number of stamps. Flowchart. Graphically depict the logical steps to carry out a task and show how the steps relate to each other. Here are some of the flowcharting symbols. Flow lines, used to connect symbols and indicate the flow of logic. Terminal, used to represent the beginning or start or the end of a task. Input, used for input and output operations such as reading and displaying. The data to be read or displayed are described inside. Processing, used for arithmetic and data manipulation operations. The instructions are listed inside the symbol. Decision, used for any logic or comparison operations. Unlike the input, output, and processing symbols, which have one entry and one exit flow line, the decision symbol has one entry and 2 exit paths. The path chosen depends on whether the answer to a question is a yes or no. Another flowcharting symbols are the following. Connector, used to join different flow lines. Off-page connector, if you want to indicate that there's another flowcharting symbol on the second page. Predefined process, used to represent a group of statements that perform one processing task. And lastly, annotation, used to provide additional information about another flowchart symbol. Here is an example of a flowchart. From our previous problem statement, determine a proper number of stamps of a letter. So we will start by using the terminal symbol, start, and then for the input, read sheets. For our processing, set stamps, sheets divided by 5, and round stamps up to the next whole number. And for the output, we have display stamps. To end, we have to make use of the terminal symbol again. Divide and conquer method. Use in problem solving. Take a large problem and break it into smaller problems, solving the small ones first. Breaks the problem down into modules. Statement structures. We have 3. Sequence, decision, and looping. Sequence, follow instructions from one line to the next without skipping over any lines. Decision, if the answer to a question is yes, then one group of instructions is executed. If the answer is no, then another is executed. Looping, a series of instructions are executed over and over. So here is an example of a sequence flowchart. From the previous problem statement, so again for the number of stamps, we have start, read sheets, set stamps, round stamps to the next whole number, display stamps, and end. As you notice, the instructions are written or displayed in sequence position. So no procedure is skipped over the other. Next is the decision flowchart. So is the condition true? If the condition is yes or the condition is true, it will go to the process step 1. If the answer is no, it will go to the next process. And lastly, we have the looping flowchart. Do while condition is true, process steps, loop. So this is the looping flowchart. Is the condition true? If it is yes, it will go to this process and then go back until the condition here is met. If no, it will go to another process. That ends our discussion for today. Thank you for listening. See you on the next one.